Number 75. How can it be demonstrated that colloidal particles are electrically charged? Okay, so in this case, we're basically talking about, can these colloids, or these specific particles in a colloid, aka colloidal particles, can they be electrically charged? Well, electrically charged just means that you have to have some type of charge, right? Either it's going to be a positive or a negative. Now, how can we determine if these particles are charged? Well, let's hypothesize a little bit. Let's pretend that we have a particle, right? Here's my colloidal particle, colloidal. And we're going to pretend that it is electrically charged, which means that it should either be a positive or a negative. Let's just say that it's a positive. Now keep in mind the big rule in chemistry, one of them, is that opposites attract each other. So there are different types of cells in electrochemistry in which we can, discuss about being, electrically charged. There are voltaic cells, there are electrolytic cells. You'll probably get more in depth into these types of cells once you start doing your electrochemistry chapter. But just know that those cells are basically the housing components of having positively charged species and negatively charged species. Now in this case, we're going to throw this colloidal particle in a electrolytic cell. And in your electrolytic cell, you technically should have something called electrodes. And those electrodes also have charges to them. Now let's pretend that, we have a big electrode here, which I'm just going to draw as a rectangle. And maybe I'll just make this nice. We'll have a little border on it. Let's have some fun, right? We got some borders on here. Beautiful. And this is my electrode. Now, in this electrolytic cell, you're going to have two electrodes, right? One should be technically positive, and the other one should be negative. Now, opposites attract. If we want to find out that this colloidal particle is charged, what charge should I make the electrode in order for this particle to travel to the electrode? Yeah, you got it. This electrode should be filled with negatives, so that your colloidal particle attracts to the electrode. And now, once the particle comes in with the electrode, so once the colloidal particle and the electrode meet, this will neutralize the particle, because positive basically means that you're losing electrons, right? Or you have less electrons than your neutral component. Negatives means that you're filled with electrons. So in this case, positive plus a negative means neutral. You have no charge. And once you neutralize the particle, that's not the colloidal particle anymore. It will change its shape. So, zero charge. And it'll change its shape, meaning in a different form. And what's going to happen, generally, is that it's going to form a precipitate. Now, chances are that the precipitate is going to be collected in the form of dust. And once it's collected in dust, which is a neutral particle, it gets swept up and, it goes out of the atmosphere. But basically, that's how you can demonstrate if they are charged. You place them in an electrode that is a different charge than them. The particle will be attracted towards the electrode, and if it is electrically charged, it will form a neutral substance, and it will change into a precipitate, aka dust. And that's the whole demonstration. So I hope this helped. Let me know in the comments thank you so much for viewing the video, and I hope you're having a great day out there. Keep studying hard, and always keep learning, okay? I'm with you guys every step of the way on this channel, so come learn, all right? Nothing better than having a study buddy 24/7. We also have some goodies in the description box. We got links for you guys that might help you out in your classes. So always come back, always check the description links. We always update them when we got new stuff for you. All right? Okay. I'll talk to you soon. Have a great day. Bye-bye.